welcome back to Level 6 Math. I'm Mr. C, and today we're looking at Saxon Math Lesson 38. Now you see that there are a lot of learning objectives today. The good news is that these are things that we've covered in some way in previous lessons. So today's mostly a review with a few small new additions, okay? So we're looking at writing whole numbers with a decimal point, adding decimal numbers and whole numbers, subtracting, and then squaring a number. That's kind of the new thing today, is using squaring and learning how to use exponents, okay? So here Margie has this sign, t-shirt closeout $3 each. What's another way to write $3? We can write it with a decimal point, 3.00, okay? We might see dollar amounts with or without a decimal point, so it might be 3 or it might be 3.00. But the truth is, there's lots of ways to write the number 3. You could do 3.0, 3.000. It depends on how you want to line up numbers. The important thing, and we've covered this in a previous lesson, is lining up the decimals. So if we're adding and subtracting numbers that have decimals, we want to make sure that that decimal is lined up. So here we see a paper is 11 inches long by 8.5 inches wide. That's kind of the standard sheet of paper, 8.5 by 11, okay? Find the perimeter of the sheet. Well, all you have to do is add 8.5 plus 11 plus 8.5 plus 11. That gives you all four sides. So we get 11.0, 8.5, 11.0, 8.5. You don't have to write the 0 in, but for some people it helps. Then you can just add them up, and when you do that, you get 39 inches as the perimeter, okay? Make sure you get all four sides. So subtract 12.75 or subtract 5 from 12.75. Again, if we just add a decimal to this, 5.00 is the exact same thing as 5. It just makes it easier to line these up to subtract. So we can take 12.75, subtract 5.00, then we subtract those zeros and we get 7.5. 12 minus 5 is 7, and we end up with 7.75. I know you've done this before, we're just practicing, and the big thing here is lining up the decimal. Okay, now here we see the area of a square by multiplying the length of a side of the square by itself in a square. If it was a rectangle, it would be the length times the width. Here the square has 5 centimeters by 5 centimeters, which we know from a previous lesson, 5 times 5 is 25, and centimeters times centimeters is square centimeters, or centimeters squared. So here we get the area of 25 square centimeters. From this model, we say we have the expression squaring a number. So 5 squared is 5 times 5. Squaring a number is important because that leads us into exponents. Exponents are simply squaring a number. So here we use the exponent of 2 to say 5 squared equals 25, or 5 times itself, that base number, where we use that as a factor. So 5 times 5 is 25. It's not 5 times 2. We know 5 times 2 is 10. But 5 squared is 5 times 5, or 5 times itself. That equals 25. So what is 12 squared? Well, 12 squared would be 12 times 12, which we know from our math facts is 144. So that one's not too tricky. Simplify 3 squared plus 4 squared. All we have to do, we're not doing 3 times 2 plus 4 times 2. Remember, in order of operations, we do parentheses first, then exponents. These are exponents. So we do 3 times itself plus 4 times itself. So 3 times itself is 9, 4 times itself is 16, 9 plus 16 is 25. Okay? What step are we not showing? We're not showing 3 times 3 and 4 times 4 because it's already written there. That's what 3 squared means, is 3 times 3. So we don't have to write it out like this. If you think that's going to make it easier for you to write it out, go ahead and do that. You can add that extra step if it helps you to mentally go through it, but it's not required. So what is the area of a square with sides 5 meters long? Well, we know that a square is the length squared, or times itself. So 5 times 5 is 25, and meters times meters is meters squared. So we get 25 meters squared. Here they wrote that extra step. 5 times meter is 25 meters squared, or squared meters. When they write it out, they always say squared first, but when you write it like this, you put the square symbol after the measurement, in this case meters. If we know the area of a square, we can find the length of each side. We're just going to do the opposite. Instead of squaring, we're going to take the square root. And so in something that's 49 centimeters squared, we can square that by dividing it. We're thinking, what number times itself equals that? Well, we know 7 times 7 is 49. What times itself equals centimeters squared? Centimeters, of course. So we know that it's 7 centimeters, because 7 centimeters times 7 centimeters equals 49 centimeters squared. That is the square root. So we haven't done square roots up to this point, but it's just the opposite of squaring something. So finding the square number, root of a number is the inverse of squaring. 6 squared is 36, so the square root of 36 would be 6. And that leads us into perfect squares. So any number times itself is a square, and we can look at that as a perfect square. That'll be on the next slide. Let's look at this first. We read 100 squared as the square root of a 100. This expression means what positive number, when multiplied by itself, has the product of 100. Since 10 times 10 equals 100, we know that the square root of 100 is 10. So just, to go through that one more time. Here's that perfect square I was talking about. It's a square root that's of a whole number. So starting with 1, the first perfect square is 1 times 1 is 1, then 2 times 2 is 4, 3 times 3 is 9, and you just see it's getting bigger and bigger, and all we're doing is we're taking the next whole number and squaring it. So we have 1 squared, 2 squared, 3 squared, 4 squared. The next one would be 5 squared, which is 5 times 5 equals 25. So if we drew this out, you'd see 25 blocks. Simplify 64. Well, what times what equals 64? 8. We know 8 times 8 equals 64 because we learned our math facts. So 8 times 8 equals 64, so the square root of 64 is 8. And that does it. This is a fun lesson. It's mostly review, but now we get to practice squaring and taking the square root of something. This is something we'll continue to use in other lessons, so it's good to practice it. Have fun. Good luck.